Hello friends, so welcome to today's video on Two-Way ANOVA. Today I'm going to explain all the steps involved in calculating Two-Way ANOVA. I'm Dr. Sujit and welcome to my channel Learn and Fun. Before I start Two-Way ANOVA, it's a good idea to spend some time on One-Way ANOVA first. Those who have not seen my previous video on One-Way ANOVA, I highly recommend you to go and watch that video and get familiar with One-Way ANOVA. Still, since I'm starting this Two-Way ANOVA, it's a good idea to explain it briefly in this video as well. So, you remember the data set that we used, the score of students from 3 sections, and we wanted to check whether the 3 sections are distinctly different or they belong to the same family. And we used One-Way ANOVA to do that, and our result was this groups were actually this same, and there is no difference between the mean variance in these 3 groups. Anyway, so One-Way ANOVA basically takes one factor, and in this our case it was section. Okay, and how did we calculate the sum of square between the groups and sum of square within the groups to get F score, and we compared it with F tabulated, is all explained in this slide, which is visible on your screen. So what we did, we first calculated total sum of square, which is equal to sum of square between groups plus sum of square within groups. Within groups basically is also known as error. Okay, so once we calculated all these 3 things, then we also calculated the degree of freedom of these sum of squares, and then we basically found the value of F, and we compared it with the tabulated value of that with respective degree of freedom. We decide on rejecting or accepting the null hypothesis based on this value. Okay, so now what is the difference in Two-Way ANOVA? Two-Way ANOVA basically follows the same process, but instead of having only one sum of square between groups, now we have got some more because of the factors, and here we have 2 factors. So here the first one is the same, which is section, and the second one is gender, where we have 2 categories, male and female. Okay, so this is the data we have. Now let's see what is the difference in Two-Way ANOVA. Two-Way ANOVA, the first part is the same, SSP due to factor 1, and previously we had sum of square within the group, which we called that as error. So now some of these errors can be explained now using factor 2. Some of the error again can be explained using the interaction between 2 factors F1 and F2, and then the last one is error. Okay, so now the sum of square, previous sum of square, is now divided into 3 parts: sum of square due to factor 1, factor 2, an interaction, and the error term. So this is what we are going to do, and this formula is very simple. So the same, TSS is equal to all this addition of all these things. For deciding on ANOVA, you need to arrange your data in this fashion, so that very easily you can use Excel to decide on the values of ANOVA, all the sum of square, degree of freedom, and F testing up to F testing. You can get it through ANOVA. So let's go to Excel and see how one can get the value of these things in. So when you get into Excel, you can see that now the table is exactly the table that you have seen just now, with 3 sections and 2 groups from the gender, male and female. So in order to calculate ANOVA in Excel, what you must check whether your Excel has this button or not, data analysis. If you do not have data analysis button, then quickly you can go to file, then you click on options and add-ins and manage Excel add-ins. You click on go, and if you click, you can get analysis tool pack and analysis tool pack VBA. Click both and say OK. Once you say OK, this button automatically will start appearing. And once you have this button, click on this button and select for ANOVA 2 factor with replication, and you click it. So what you are getting is the input range. Input range is nothing but the whole thing that you, because ANOVA actually calculates automatically this. Okay, so now rows per sample. Rows per sample is again 1 2 3 4 5, that is 5 in one row. So you can put it like that in one group, and then the level of significance you can choose 0.01, or if you want to make it 5%, you can make it 0.05. And then you select your output range, where you want your output to be showing your result. So I will select here somewhere. Let's click here. So H5 is going to be the start of my result, and then click OK. So once you click, you get the summary for male, summary for female. This is the group you are getting, and total, and then the final ANOVA table is here. Okay, so if you see ANOVA table, you can find that the values are given. Sample is sum of, this is sum of square 147.68, degree of freedom is 1, this means sum of square, this is F calculated, this is probability of F based on the critical value which is mentioned here, like that column, like that interaction, and this is the error term which is within. Okay, and this is the total which is there. Okay, so these are the degree of freedoms that you have. That I have taken the same result here just to show you that we are going to find out all these values and the procedure to calculate these values. Okay, so now the first one is total sum of square. When you say total sum of square, you have to bring the table like this fashion, stacked together, section A followed by section B and then section C. Okay, and here the marks, you have to find the mean of these one. So mean is 82.39, and then from this mean you find the deviation and then square it. So this is the first observations deviation from the mean and square, and followed by the second one, and like that you continue, and then you get the total. And once you get the total value is in this fashion. You are getting 1775.64. This is what is your total sum of squares. Okay, so this total sum of square is going to be very critical in our analysis. Okay, so you can see that here the blue one, which is mentioning from the final table. So I am mentioning this with n is for degree of freedom is n minus 1, n is 30 minus 1, which is 29. Okay, so just remember this and we will use at some point. Okay, so now once you are clear with total sum of square, now we need to get into the betweens and then errors. For that, what we need to do is we need to convert our table in such a fashion so that we only have mean for each part. Okay, so like three sections we have, and male, female, two groups from the gender, and you can see that this is very interesting table where you can see that 76.50 is the mean of male members in section A. Same thing is mean of male members in section B is mean of this in section C. Like that we have done, so that you get from here you can section A male mean is this much, and section A female mean is 84.88, and then the grand mean of section A is 80.69. Like that if you do for all section B, section C, and then you get the final one. Final is exactly the same which we got just now from total sum of square as well. Okay, so this is the grand mean which we are going to use for our deviations. Okay. Now let's say SSB with two factors. We can get sum of square between with factor 1 first and then factor 2. For 1, what you need to do is you need to take the deviations from this grand mean. So the first number is 80.69. Can you see that? That is that minus the grand mean, which is 82.39, and then square it. The second one is again this same, and third one is also the same. And once you add this, you get sum of square between for factor 1, and that value is 12.83, and that is multiplied by n, where n is number of observations in that group, and here the number of observation is 10, so it is going to be 128.3. okay, so now the next one is from the data side. We have two averages, so male averages and female averages. We take deviation from the grand mean and then we add it, and in that case we are getting the value as 9.85, and this is multiplied by n. In this case n is 15. Why 15? Because total number of observation is 30 and we have two groups, so each has 15 observations, so we are multiplying it with 15, so it is getting us the value 147.68. so that is the value. So first two factors sum of square we got it, and now we go to their degree of freedom. Degree of freedom is very simple. So if you see, the sum of square is 128.3 and degree of freedom is nothing but number of groups minus 1. So that is how you are getting for sections. There are 3 sections, minus 1 is 2. Gender we have male and female 2, so 2 minus 1 is 1. okay, so mean sum of square from this we can easily get, because sum of square divided by degree of freedom is mean sum of square. okay, and here 147 divided by 1 is 147 only. F ratio and F tabulated value I will explain once I calculate SSW, because for F ratio we need to have this value. This is known as sum of errors, or you can say sum of squares within. So for within, it's very simple calculation. You can see that here each group in section A, that is female and male, is the observations you need to take, and then their respective. For example, 94.75 is the observation in the section A, and it is falling in the category of female. So you need to take deviation from the mean of section A for the female, which is 84.88. So like that if you do, then you should square it. Of course, like that you can do for all based on their respective means, and then calculate. Then you get a value which is known as sum of square within, which is 1379.78. That basically means 1379.78 is actually not explained by either factor 1 or factor 2 or its interaction. So you can interpret this way as well. Okay. So here one more interesting thing is the degree of freedom calculation of this value. So it is going to be very simple. If you take number of observation as 15 minus you take 3, which is number of sections, so that becomes 12, then multiplied by 2, which is number of rows. So in that case you get 24, or else you follow this method 10 minus 2 into 3, so that is also going to give you 24. So 24 is the degree of freedom for sum of squares within. Okay, so now once we are clear about sum of square within, the next is sum of square for interaction. This interaction becomes little complicated if you want to use the formula. I'm going to use both, right? For example, now for sum of square for interaction, there are two ways one can follow. First, let's understand what exactly is the meaning of this. When you say interaction, what does it mean? It basically means that the line through mean that you are going to find is actually not parallel. So that basically means there is a possibility that these are interacting. Like in this case, the first two numbers between male and female in section A is very far, okay, but in section B it is actually intersecting, and then section C again it is very far. So there must be some reason why in section B they are interacting and why not A and C, and what is that value of that interaction we are trying to find in this calculation. So one easy way of finding the calculation is, since it is like additive thing, so you already know the value of TSS, SB, sum of square between factor 1, factor 2, and then SSW. So you just put the values and get the numbers for SSB for interaction. So here we are getting somewhere close to 119. Okay, but I am going to use a formula to get this. So this basically means a very simple calculation, which basically takes you individual mean in this group and see the difference with that particular group across that section, and also in this the other group, which is gender. So section wise difference as well as this difference you are calculating, and then you are adding this particular number. So let's see how it goes. So here you can see that it is 76.50 minus this one representing section A, and then you are finding out this which is representing male, so then plus the grand mean. So that value is around 1.97, square it, and that gives you 3.89, and this 3.89 is presented here. Likewise you can find the same for other numbers, and like this you will get 6 numbers, and these 6 numbers are added, and once you add all these 6 numbers you are getting the value as 23.97. This 23.97 is multiplied with number of members in each group, which is equal to 5. So just multiply by 5 and you are getting the value as 119.84 basically, and that exactly is the number that we are getting. So now once we have this number, you can see that this is the tabulation we got from ANOVA through the formula that we used, and this is the one we calculated one by one, and you can see that the numbers are exactly matching. 128.3 is nothing but column, then again for second one is nothing but 147.68 is for gender. Interaction is 119.84 here, and within is 1379 is this. Okay, and degree of freedom is exactly the same. So mean sum of square is nothing but sum of square divided by degree of freedom. So you are getting the F calculated ratio, which is also matching perfectly with the one which we did. 2.57 here, 2.57 here, 1.11, this is basically 1.12, so here also it is 1.12, and it is 1.04, it is also 1.04. And tabulated value, you have to understand that tabulated value is calculated through their respective degree of freedom. So how did you get F ratio? First let me just tell you that. So mean sum of square is there. This is divided by the error term. Okay, divided by the error term, you are getting this 147.68 divided by 57, you are getting 2.57, and 59.91, this is divided by 57, you are getting 1.04, like that. So what is the tabulated value? How do you get tabulated value? It's like F for this degree of freedom 2 and 24. So that is what 5.61. And for this, how much is the value of F? So it's like F1, numerator's degree of freedom, and then denominator's 24. So it's 7.82. And similarly, you are getting that for interaction as well, which is the same as the first one. So it is 5.61. So our results are exactly same with this. So I hope you understand. And so testing part is very easy. So since F ratio is less than F tabulated, can you compare here these two numbers, and you can see that these numbers are always higher than this number in this case. So we can again say that gender and sections are not that great enough to reject the null hypothesis. So null hypothesis is accepted. The null hypothesis was that gender and there is no difference between gender and among groups. So that's it for today's class. I hope you are doing well, and keep learning and be happy. Bye bye.